Welcome back to our YouTube channel. We are back in our channel today with a powerful concept in chemistry that we want to discuss with you, our viewers. Today we want to talk about the concept of organic chemistry. And the reason why we are bringing this concept back to our platform to discuss with you is because we found out that most students find this topic very difficult to understand. And we are coming back here to simplify this topic and to bring back this topic to you in a manner that it will be very simple for you to understand and to comprehend. So in this topic that we want to discuss, we have so many aspects of this topic that we want to discuss with you. But because this topic is very tasking and is very large, is very voluminous, we are going to have different series of this topic that we are going to treat with you on this YouTube channel. But today, I just want to talk about an aspect of this organic compound that I want to deal with today. And what I want to deal with today is how to know if an organic compound is aromatic or not. So today, what I'll be doing with you, or the lesson that I'm taking with you today, is to treat with you how you can recognize an aromatic compound. And I'm going to go step by step, treating this topic and to let you know in full details how to recognize an aromatic compound. So let's go into the lesson. First thing, for you to know if an organic compound is aromatic or not, you have to first know the properties of an aromatic compound. And first thing is to let you know this property, so that if you can see this property in an aromatic compound, then you'll be able to know if that compound is aromatic or not. So let's go to properties of an aromatic compound. So the first property that I want to mention is that for an aromatic compound to be aromatic, it must be cyclic. First thing is that what? It must be cyclic. It must be a cyclic compound. Or I can say it must be a compound that's in a ring form. Number two properties of an aromatic compound is that it must be planar. An aromatic compound is a planar structural compound. What does it mean to be what? To be planar? That means that all atoms in the structure must lie on the same plane. And also, it must be sp2 hybridized. Number three property of an aromatic compound is that it must be conjugated. It must be conjugated. What does it mean to be conjugated? It means that it must have an alternating single bond to double bond. In the structure of that aromatic compound, there must be alternating of what? Single bond to what? To double bond. And the fourth properties to look out for in an aromatic compound is that it must contain a delocalized pi-electron. It must contain the delocalized pi-electron. So every aromatic compound must have what? Delocalized pi-electrons. Delocalized pi-electrons. So for an aromatic compound to be called an aromatic compound, it must have these four properties. It must be cyclic, it must be planar, it must be conjugated, and it must have delocalized pi-electron. Now, in addition to these four properties that an aromatic compound must contain before you can know if an aromatic compound is aromatic, in addition to this, it must also obey Hückel's law, or it must obey Hückel's principle. Hückel's. Alright, so it must also obey what? Hückel's rule. Alright, what does it state? It states that if a compound is cyclic, planar, and conjugated, and it has 4n plus 2 pi-electron, it means that that compound is aromatic. That means that in addition for a compound to be cyclic, planar, conjugated, and have delocalized pi-electron, it must also have 4n plus 2 pi-electron. That is what this Hückel's rule is talking about. It must have 4n plus 2 pi-electron. That means that the pi-electron that is inside the compound must be 4n plus 2 pi-electron. What does this n mean? This n means what? It means a non-negative integer. Alright, this n starts from 0 and mostly it stops at 6. Mostly it stops at what? At 6. So our n is 0, 1, 2, 3, 4, 5, 6. Alright, so we want to know if a compound is aromatic, it must have 4n plus 2 pi-electron. So how are you going to do is that we'll be slotting this integer into this formula. For instance, if you put 0 into this formula, that means that we are going to have 4 times 0 plus 2. That will give us 2 pi. If we slot in 1, we have 4 times 1 plus 2. That will be 4 plus 2, that will be 6 pi. If we slot 2, we have 4 times 2 plus 2. That will give us 10 pi. And so on and so forth. That means that for a compound to be aromatic, in the structure, it may have 2 pi. If it has 2 pi, it's aromatic. If it has 6 pi, it's aromatic. If it has 10 pi, it's what? Aromatic. In addition to all these 4 properties. So for a compound to be aromatic, we now have 5 things that we have to consider. It must be cyclic, it must be planar, it must be conjugated, it must have delocalized pi-electron, and it must obey Hückel's rule. Do you understand? If it has these 4 properties and it does not obey Hückel's rule, it's still not what? Aromatic. So now, I would like us to look at some structure and examine them together to use this what? This rule or this property to examine if they are aromatic or they are not what? Aromatic. So let's go to the example of the structure and let's look at it together. So let's look at this following structure together and to use those properties to know the one that is aromatic and the one that is not aromatic. Now let's start from this first structure. This structure is called benzene. Now this benzene is what? Is cyclic. First thing is planar. The next thing is conjugated. We see alternate arrangement of single bond, double bond, single bond, double bond, single bond, double bond. That's why we say that it's what? Conjugated. Alternate arrangement of single bond and double bond. Alright, so the next thing is that the electrons are delocalized. So the electron can move from one point to another point. The space here is the space that is allowing the free rotation of the pi-electron. And what do I mean by pi-electron? Pi-electron are other bonds apart from the first bond. So if you look at this structure now, this is the first bond. So this is the what? This is the what? The second bond or other bonds. So this other bond or the second bond is called pi-electron. And for instance, if you have now 1, 2, 3, this is the first. Let's take this one as the first what? First bond. Now this one and this one, they are pi-electrons. So there are other bonds apart from the first bond. Alright, so in this case we have 2 pi-electrons because we have 2 other electrons apart from the first bond. So also in this place also, if you come to this place also now, this is the first bond. So this is a pi bond because this and what is another bond. So here we have only 1 pi electron, but in this case we are going to have 1, 2. That is 2 pi electron. So this is what pi electron. So I say this pi electron can move from one point to another point. This one can move from this point to this point. This one can move from this point to this point. This one can move from this point to this point. That's what we mean by what? The localization of pi electron. That the pi electron can move in what? Within the structure of the benzene. Alright, so it has obeyed those 4 properties. Let's look at, does it obey Hückel's rule? Does it obey Hückel's rule? That is 4n plus 2 pi electron. So now I said our n can be 0, 1, 2, 3, 4, 5, 6. So if we install one in this benzene, in this formula, we install one here. So that we are going to have 4 times 1 plus 2. That will give us 6 pi. And you know in this benzene we have 6 pi because this 1, 2, 3. That is 3 times 2. That gives us what? 6. So we have 6 pi electron. Do you understand? In this ring of what? Of benzene. That means our n here is 1. Our n here is 1. So we have 6 pi electron in what? In benzene. 6 pi. Let's come to this place also. This structure is cyclic, is planar, is conjugated. The pi electrons are what? Are delocalized. So let's look at what we can do here. If we install 2 here, if we install our n is equal to 2 here, we have 4 times 2 here plus 2, that will give us 8 plus 2, that will give us 10 pi. And if you look at this structure, this 1, 2, 3, 4, 5, we have what? That is what? That gives us what? 10 pi electron. So we have what? 10 pi electron in the what? In that system. So this one also is obeys what? Hückel's rule. That means here our n is equal to what? 2. Our n is equal to what? Is equal to 2. Let's go to the third one. Let's come to this place. Alright, it is cyclic, it is planar, it is conjugated. Alright, the pi electrons are what? Are delocalized. But let's see, does it obey Hückel's rule? Alright, if once we it does it obey Hückel's rule. Now if we use this is 1, 2, 3, 4, 5, 6, 7. Alright, I think if we install 3, I think it should give us 4 times 3 plus 2. That is 12 plus 2, that is what? 14 pi. So also we have 14 pi electron here because this is 1, 2, 3, 4, 5, 6, 7 times 2. So that gives us 14 pi. So it also what? Obey Hückel's rule. So that means that this one, our n is equal to what? Is equal to 3. That means that this one is also what? Is also aromatic. This one is aromatic. This one is also what? Aromatic. It obeys all the properties. This one is also what? Aromatic. I think I can clean the board now. Let's come to this fourth structure. This is diphenane. This combination of 2 benzene. Look at it. Combination of what? 2 benzene. Yeah, if you look at this structure, it's combination of what? 2 benzene. So if you look at it at the end, we have 6 pi here, we have 6 pi electron here. That will give us what? 12 pi. Yeah, that will give us 12 pi. Alright, so but we are going to consider it as 2 benzene that are joining together. Because if we look at as one entity and we use our Hückel's rule. Do you understand? If we put 3 here, that will be 4 times 3, 12 plus 2, that is 14. And if we put 2 here, 4 times 2, that is 8 plus 2, that is 10. That means that this one, if you consider it as a single entity, it will not what? It will not be aromatic. Do you understand? But it's aromatic. What you just do is that we are just combining 2 benzene together. And for benzene obeys what? Hückel's rule. If you put 1 here, that is 4 times 1 plus 2, that will be 6 pi. So we have 6 pi here, we have 6 pi here. Just the combination of 2 benzene. So it's also what? Aromatic. It's also what? Aromatic. Yeah, it's aromatic. So if it's cyclic, it's planar, it's what? Conjugated, and the pi electrons are what? Are delocalized. Let's come to this 5th one. Now, if you look at this 5th one, also is cyclic. Yeah, it's cyclic. But if you look at it very well, does it obey Hückel's rule? Do you understand? Does it obey Hückel's rule? Now, if you look at it, we have 4 pi here. It gives us 4 pi, and there's no way if you install 2 here. If you install 2 here, that will be 4 times 2, that is 8 plus 2, that is 10. If you install 1, it will give us 6. If you install 0, it will give us 2. So Since it's 4 pi, it is not going to be what? Aromatic, because it does not be what? Hückel, even though it's what? It's cyclic. So all the rules must what? Must be obeyed. But now it's even though what? It does not obey Hückel, even though it has all other properties. It's still what? It is still non-aromatic. Let's come to this 6 structure. First thing is cyclic. Yeah, it's cyclic. If you look at the pi electron also, it's also what? It will be 4 pi. There's no way we are going to install any of the NEA that will give us what? 4 pi. So it's still not. This one is also what? Non-aromatic. It's not what? Non-aromatic. Let's come to this one. It will give us 8 pi. It will give us 8 pi. 1, 2, 3, 4. Now that will give us what? 8 pi. There's no way we are going to get 8 pi also here. Even though if you put 2 here, it's 4 times 2 plus 2, that will give us what? 10. You install 1, 4 times 1 plus 2, it gives us what? 6. So it does not obey Hückel's what? Hückel's. It is anti-aromatic. It is anti-aromatic. And this will first lead me to the first assignment that I'll give to us, that I want to drop for me in our comment box. You know, tell me the difference between non-aromatic and anti-aromatic. For both, we are saying that they are not aromatic, but yet there's still difference between non-aromatic and anti-aromatic. So I need that from us in our comment box. Alright, I think with this explanation, you should be able to differentiate if a compound is what? Aromatic, or if it's not aromatic. I think maybe I should still give us one more example. Let me make it 8 now. Let me draw this structure. Let's say I have something like this. Now, if you look at this, we are going to have pi electron is going to be 2. Just only 2. And if you look at it very well, if you put n is equal to 0 here, we are going to have our pi electron is going to be 2. That means here our n is equal to what? 0. And so it obeys what? Hückel's what? Hückel's rule. Do you understand? It obeys what? Hückel's rule. And it is what? It is planar. It is planar. The electron is what? Is delocalized. So is what? Is aromatic. Now, the last aspect of this video is that I want to give you with another assignment. You know, I've given you the first assignment. This is going to be my second assignment that I'm giving to you. I want you to look at this structure. Do you understand? You use the principle that I've used in this video to determine the one that is aromatic and the one that is not aromatic. So I'll be waiting for your answer in our comment box. If you have really enjoyed this video and you have really gained a lot in this video, I would like to subscribe to our YouTube channel, because there are still other aspects of this organic compound that we're going to do. You know, there are other concepts from this organic compound that I'm going to do in my subsequent video. So do wait to subscribe. Do not forget to like this video, comment, share it to your friend to also enjoy what you have enjoyed in this video. So meet you in the next edition.